Chapter 4, Lesson 2. The essential question we're answering is how can you derive a formula for the area of a triangle? The other day we did parallelograms, now we're looking at triangles. Your key idea is the area of a triangle. The area A of a triangle is 1/2 the product of its base B and its height H. So notice it says product, so you know that you're using multiplication. So the area equals 1/2 base times height. Pause the video, put the words in the algebraic expression plus the drawing in your notes, and come back. Okay, so let's take a look at example 1. And there's a light bulb, remember. It says in example 1, use the associative property of multiplication to multiply 5 and 8 first. Let's take a look at what that means. Area equals 1/2 base times height. Again, they wrote the formula, which is I'm going to ask you to do all the time. So here is our triangle. The height is 8, the base is 5. So we have 1/2 5 times 8. So the first thing they did, again, would be the associative property where they multiplied these together, came up with 40. Now we can multiply 1/2 times 40, which is 1/2 of 40, and of means times. So your answer is 20. If you can't remember how to multiply a fraction and a whole number, make sure you go back in your notes and figure that out. All right, let's take a look at the next thing. Is it reasonable? Draw the triangle on a grid paper and count unit squares. Each square in the grid represents 1 square inch. Squares that are full or nearly full are in pink, and there's 18 of them. Squares that are half full are in blue, and there's 4 of those. So the area is 18 times 1 plus, and they mean 1 meaning full, plus 4 half squares equals 20 square inches. So the answer is very reasonable. So go ahead and do numbers 1 and 2 and come back when you're done. Example 2, finding the area of a triangle. Find the area of the triangle. Again, formula A area equals 1/2 base times height. So let's take a look at this triangle. Now, notice the leaning of the triangle. Okay, isosceles. It's not straight up for one of the sides. They're both on an angle. So we can figure out the base because it says it's 12 meters. But then what we have to do is we have to draw the line out and square it off from the top point. So you can take the top point, come down, and go over, and you have this imaginary second triangle. But if it's a square corner, then you know that this is the correct height. Once it's measured, it would be 9 meters. So you substitute numbers, 1/2, 12 times 9, and once you multiply, you'll get 54. And don't forget, square meters, or meters squared. Number 3, real life application. The base and height of the red butterfly wing are 2 times greater than the base and the height of the blue butterfly wing. How many times greater is the area of the red wing than the area of the blue ring? All right, let's just move on here. This is also in your book on page 161. First it says find the area of the blue wing. 1/2 base times height. 1/2 base times height. So they filled that in. It's 2 times 1, which is 2. 1/2 of 2 is 1. So it's 1 centimeter squared. The red wing dimensions are 2 times greater. So the base is 2 times 2. Let's go back here. The base right here is 2 times 2, so this is 4, and the height is 1 times 2, which is 2. So you have 4 and 2. So you put that right in here. 1/2 of 4 times 2. And you would get 4 centimeters squared. The area of the red wing is 4 times larger. Because if you put 4 over 1, it comes out to, because here's your 1, here's your 4. If you put the labels, they cross each other off. Sorry, cross each other out. And then you divide 4 by 1, you get 4. All right, do the on your own number 3 and 4 and come back when you're done.